Now for our next feature, what I want to show you is something called reflections. Now Dremio is blazingly fast out of the gate with such features such as its Apache Arrow based processing, which I've done several long talks on Apache Arrow. So if you Google Dremio Apache Arrow, you'll find lots of content explaining sort of the power of Apache Arrow when it comes to processing data really, really fast. Which is why most data tools are now really embracing the Apache Arrow ecosystem, while Dremio not only was one of the original entities using Apache Arrow was created partially at Dremio. But not only that, Dremio has features like the columnar cloud cache for caching regularly accessed assets from your object storage, results caching, and other features to help optimize query plans and give you sort of industry-leading performance that competes with data, vertically integrated data warehouse solutions, but giving you all the bells and whistles that Dremio does. But sometimes you still need a little bit of an extra push, and traditionally you'd use features like materialized views and cubes that would require lots of management, require the analyst to be aware of these cubes and materialized views so they query the right names. But Dremio makes this a lot easier through its feature called reflections, okay, which we're going to demonstrate in this particular video. We're going to be using our weather prep dataset for this. So generally the context of this is that you are running queries on the dataset that may not be as fast as you like. Oftentimes the case really for like BI dashboards where you're doing group bys, and these are really, really large data sets. So for example, let's just do a group by. First let me run a query. Okay. Now I could either write out the group by query myself, or I could use this group by tool. Okay. And this will let me say, hey, you know what? I would like to aggregate, I would like to figure out what the precipitation is. We'll say, we'll just do the average precipitation based on the station that it occurred at. Okay, so there's my dimension, there's my measure, and then I can hit apply, and it will write that SQL. And then I can run that, and let's just see how long it takes. Again, Dremio is pretty fast, so you can see that it happened within 1 second. Okay, but again, for a really large data set, this could take a significant amount of time, depending on how large. And again, Dremio is infinitely scalable, so oftentimes, by default, Dremio probably will be fast enough to handle very large data sets sufficiently fast most of the time. But again, in those cases where you might need a little bit more speed, Dremio has this feature called reflections. And I can access that by clicking over here to edit the data set. And that's going to take me to this screen right here where I can edit the data set. And what you're going to do is you're going to click on reflections. Now, here there are two types of reflections. There are raw reflections and there are aggregate reflections. Now, raw reflections, you want to think of those more like materialized views. You're materializing the raw rows of that table. Now, if I turn on raw reflections, it's just going to make essentially a physical copy that it can swap out under the hood of the data set of the view that I'm creating the raw reflection on. But I can get more detailed. I can click on advanced here, and I can actually determine how is the data in that reflection sorted, how is it partitioned, so that way I can customize it to really be perfect for the types of queries that I expect coming in. Okay, and that's all well and good. Okay, so I'm going to go back to basic setup. But I want to do an aggregate reflection, so I'm going to flip this switch on for aggregate reflection because it's really for optimizing my group bys. I can specify, hey, which dimensions am I optimizing for? So I was doing a group by station, and again we were doing a measure of precipitation. Okay, and then I can hit save, and then it's going to create that reflection. That's going to essentially pre-compute all the different aggregates for precipitation grouped by station. And again, basically, the more dimensions and measures I choose, the more it'll save. Okay, so see, the reflection has been created. Now, if I go back and I run that query again, okay, I hit run. Okay. Cool. Now I can see that it happened with under 1 second. Okay, so it happened a little bit faster. Again, you're not going to notice too much of a difference with this level of data set. What I'll do is I'll show you a different example with a much larger data set in just a moment. Okay, so here we go. I go to my jobs page. Now notice that when we ran the query the first time right here, there's no exclamation point here. Okay? Or no lightning symbol. When you see a lightning symbol, that means that the query was evaluated and it realized, hey, there's a reflection that can speed up this particular data set. Let's do that. Now, again, I'm running this off my laptop, so my laptop only has so much RAM, and it's also running Postgres, MinIO, and all these other things. Now, in the sample data set within Dremio, there is a much larger data set, okay, that will take a little bit of time to run on your laptop. That is the New York City taxi trips data. So I'm going to do the taxi trips iceberg because that's going to be the most performant one on my laptop, because iceberg is generally going to be always get you sort of the best performance because iceberg is awesome. But I'm going to format this folder. So I'm saying, hey, this folder has an iceberg table in it, and I want to recognize it. And again, it's going to take a second for it to generate the preview because this is it's a data set of 300 plus million records. Okay. So there it goes. Okay, and now let's say I want to figure out how many, just to confirm so you can see how big this data set is. Let's just do a count, okay, of everything that's inside of it. Okay, and let's just see how long it takes just to do the count. Because again, very big data set, should only take a few seconds as it counts the records in this data set. I think, and there it is. Yep, 12 seconds. So you can see here this data set, and again, this is all running off my laptop, so all that processing is being done by my own personal computing power. Now, Dremio typically in production would be deployed to a cluster of much more powerful computers, either on-prem or in the cloud. But you can see here it's over 300 million records. Okay? Cool. Now, now that we've demonstrated that this is a fairly large data set, okay, let's try to do a group by on this. Okay, so what I'm going to do, we're going to do, well, first let me go back to the normal data set. So actually go back to here, I'll go back to samples, New York City trips iceberg, so that way it has a full schema right there. Okay. And what I'm going to do is I'm going to do limit 1, just to speed up this initial query. Okay. Okay, there we go. We got the first record, but now we have the schema, so we can do a group by. I'm going to get rid of the limit 1. Okay. Okay. And what I want to do is, based on the number of passengers that were in the vehicle, I would like to get the average fare amount. So figure out, hey, what's the average fare for a trip with 1 people, or a average fare for a trip with 2 people. Okay, and the average tip amount. Okay, and now we're going to apply that, so it gives us the SQL. Awesome. I'm going to get rid of the limit 1 because I want to do this on the full data set. Okay. And I'm going to run this, and this is going to take several minutes. So I'm going to pause the video while it runs this because it's, again, a very large data set running purely off my laptop's computing power. So I'm going to hit run, and it is off to the races. I will see you when it completes. And then I'll show you how we can take this multi-minute query and turn it into a sub-second query using reflections. So you can really see reflections at work. Okay, so that ended up completing in 2 minutes and 31 seconds, which is pretty good for my laptop. Okay, we're talking about a, not the same kind of computing power you'd be running in production, being able to actually run this query on a very large data set in 2 minutes and 31 seconds, doing all those aggregate calculations. But that still took a sec. So what I can do is I can make this faster by basically working with that data set to turn on reflections. So I'm going to head over here. I'm going to go over to my sample data set, and I want to go to table, and again there's reflections, and then I'm going to just kind of choose the dimensions that I was querying for. So in this case, this was passenger count. Okay, and we're also querying for trip distance in miles, but I'll just kind of capture all of these. and then get rid of that one there. So now what's going to do, it's going to go generate those pre-calculations. So if I can turn on reflections, hit save, I'll give it a moment to go then pre-calculate that data and then save the resulting reflection or that cube. And the cool thing about these reflections is that they'll self-update. So basically they'll update on a cadence, and you can trigger automatic updates to these. So that way it makes it much easier to kind of keep it in sync with the data you generate them on. That's the beauty of reflections, is they require a lot less management because they will kind of automatically update. And then even better, if they're on Apache Iceberg tables, they will generally literally automatically update and then incrementally update, making those updates very, very fast. But I'll be right back as soon as this reflection finishes generating. Okay, so now that's generated, and you can see that this reflection only takes up 30 KB. So probably what's like a maybe multi-gig data set, in order to accelerate it, only took 30 KB, because again, these are generally very optimized, very performant sort of materializations to kind of achieve this acceleration. But now if I head over back to my SQL runner to run this query again, okay, let's run it. And see, this time it took a second. Okay, so we went from taking 2.5 minutes to a second. And if I run it again, it'll be even faster, less than a second. Okay, so as you can see here, just that one feature, and again, I didn't have to change the query at all. That's the other thing to kind of really keep in mind here. Okay, usually what would happen is that you would create something like a cube or a materialized view, and then you have to tell the analyst, hey, update your queries to point to this object instead of that object. But Dremio handles the swapping of what's sort of being physically scanned under the hood. So essentially, if I'm the data engineer who created the reflection, the data analyst would just basically keep running the same dashboard or same queries that they were already running and just notice that they're running a lot faster. Okay, this makes the experience a lot better for the analyst because they don't have to change what they're doing. They can just ask for acceleration and it can be created for them. But this also makes the experience really great for the data engineer, where it makes providing that acceleration much, much easier. And that's why reflections are such a powerful feature inside of Dremio. And you can see that firsthand here in more sort of stark contrast when you're seeing with sort of the performance of my own personal laptop. So I'll see you in the next video.